Well, good morning, everybody. Thank you very much, Prost and Professor Cave, for inviting me back here today. I came to this college 45 years ago this month, actually. So, and I tell you, this room has not changed. You needed that sign in 1979 because every single one of you would have been smoking in this room, and King's was notoriously sort of bad for that kind of thing. King's did, so just to echo a little comment made by the provost a minute ago, King's had the unique place at Cambridge for being the first men's college to admit women, which had happened a few years before I showed up. And I'm delighted that Provost Tet is the first woman provost, though it's a shock and a disappointment that it took quite so long for the college to realise that women could actually be provosts as well as students. But anyway, there we are. Okay. What I'm going to do in the 5 or so minutes that I've been allotted is to wind the clock back even further than 1979. I'm going to take you back to 1947, which is when all this began. And you're going to say, no, he's got his chronology all wrong. The paper wasn't printed in 1940. I'm going to take you back to 1947. There's a reason for that. 1947 is the time when, after World War II, the technological developments that had taken place at Bletchley Park had stimulated the idea that the concept of a programmable multi-purpose computing machine might actually become a reality. The thing that Alan Turing had, in a theoretical sense, sort of conceptualized in his 1936 paper on computable numbers, which hopefully Professor Cave will let me talk about that a little bit later on this morning. But so we've got this idea that you could have machinery that could do more than one thing. And just pause and think about that, because we're so used to the multi-purpose computer that the idea that that was radical in an era where machines were designed for single purposes. The way I look at this is that if you go into your kitchen and you're confronted with a toaster, you cannot fry an egg in the toaster. It would go horribly wrong. You cannot use the dishwasher to clean the floor. Well, you can if it leaks, but that's sort of, that's a bit of an error. The idea of a machine that could be told what to do and do something differently because it happens to be Tuesday morning was very, very remarkable. And yet, in the immediate post-war years, the possibility of that sort of thing was becoming real. And here's where it all got quite interesting. That concept was seized upon by the mathematicians, not by the business folk, and not by the sociologists, and not by the proto-social media engineers. It was seized on by the mathematicians because they thought, this is great. We can do big sums. In other words, what they thought they could do was fire large numbers of young women, because computers were young women who sat at desks operating adding machines. And yes, the algorithms needed to get the young women to work out how to do a complex calculation like a differential equation using adding machines. That was quite difficult, but the women were basically acting as automata. They could all be fired. We could save all their wages because we could get the computing machine to do the work of the computers. And that's what computing machines were for. And it was remarkable that they even thought the computing machines was a plural concept. When Alan Turing was hired by the National Physical Laboratory in 1945, his mission was to build the country's computing machine singular. We were only going to need one because there are only so many ballistic trajectories that you need to calculate in any given year. In fact, they thought that was a bit imprudent because the machine might break down, so it would be sensible to have a backup, so they thought they might actually build two. The United Kingdom was going to be world leading with 2 computing machines. Gosh, okay. But here's the point that Alan Turing is wrestling with in 1947. Here he is, he's at the NPL, he's designed the automatic computing engine. They're now going to take another 12 years to build the wretched thing because that's how public procurement projects go. Sound familiar? 21st century. Okay, they didn't actually manage to get it switched on until 2 years after Alan Turing was dead. He designed it in 1946, and then he started writing programs for it, even though it didn't exist yet. And he had at the back of his mind this notion that there is no fundamental distinction between data and the program itself. It's all about symbolic logic. You can take a piece of data and it looks exactly the same as a machine code instruction. Interesting thoughts that you could then treat the program itself, because that's just a string of symbols, as a piece of data, and then you can get the computing machine to modify its own instructions. This is only one step short of self-modifying programs, or what these days we might call machine learning. This is not doing differential equations and firing large numbers of women computers. This is thinking about computing in a radically different way. So in 1947, Alan Turing goes to the London Mathematical Society to give a lecture on the computing machine that he has designed for the NPL. And yes, he spends the first half of the talk actually talking about the computing machine, and a room full of mathematicians gobble it all up. They're very excited. And then the second part of his talk, he goes off on one. He goes right off on one. He starts talking about machine learning, and he starts talking about machines showing inventiveness. And he comes up with this idea that if a machine is to truly show intelligence, then it should abandon infallibility. It should have the capacity, as you were mentioning earlier, to make mistakes in order to have inventiveness, imagination, and to think of things that hadn't been thought of before. I wonder whether when we get to the end of today, anyone will have decided that today's versions of AI have demonstrated that capability of inventiveness, as opposed to recycling old ideas in new ways. So I put that as a question rather than a statement, but we'll no doubt debate that later. Okay, this is 1947. He's talking about machine learning, and everybody's saying, what is this guy on? And can we have some too? But that's very interesting. 1948, he's basically been seconded back to Cambridge from the National Physical Laboratory because there's nothing for him to do at the NPL. There isn't a computer yet for him to run his programs on, and it would be safer to have him away from the mathematicians. So Cambridge is a good place for that, where he can sort of fantasize about things like machine learning. And he writes this paper on whether it's possible for a machine to show intelligent behavior. It's called Intelligent Machinery. The NPL refused to publish the paper because they said it was a piece of science fiction, a schoolboy's essay, not a proper scientific paper. Didn't get published until decades after Alan Turing had died. So that little effort to try and get people to think about computing machinery in a more imaginative kind of ways than just doing sums, that had failed too. 1949, he's now at Manchester. Sir Geoffrey Jefferson, who's a brain surgeon, top-class brain surgeon, quite one of the most interesting and remarkable people to have lived in the mid-20th century, stands up in front of a room full of medics giving something called the Lister oration. And he is talking about the computing machine that they have built at Manchester University. And he puts forward this idea that it is completely absurd to imagine that computing machines have anything in common with human beings, particularly in terms of the way that they think about things. Is it possible that a computing machine could think? Of course not, says Jefferson. You know, imagine a computer sitting down and writing a sonnet. I mean, don't be absurd. There's a journo in the audience. Sorry, Provost Tepp. There was a journo in the audience, and the journo came from the Times. And the journo picked up on Jefferson's remarks about this idea that there was this electronic brain at Manchester University and this question about whether machines can be said to think. So they phoned up computing lab at Manchester University. Professor Max Newman was unfortunately out of the lab that day, and so they got the number 2 guy. Number 2 guy was a certain Alan Turing, who started to wax lyrical to this journalist about, you know, the possibilities of what this is only a foretaste of what may come. And this is a computer which has got a memory of 1024 bits. It could just about add 3 and 5, and he's talking about the possibilities of computing machinery in the future. The Times gets very excited about this, and there's this long correspondence in the Times between bishops who are talking about humanity and all this stuff. That's how we come to have the paper that's printed in Minds 75 years ago, and the reason we're all gathered here today. This is the debate about whether computers are in fact ginormous calculators or whether they have other capabilities. And this is why Alan Turing says in his paper, I think it's actually kind of the wrong question to ask whether computers can think. What we really ought to be talking about is what the limits, if any, are on their capabilities. And I think that's probably setting the scene for today. I'd just like to finish with one final thing about the Turing test itself, this whole imitation game business. He's using that in this 1950 paper to just try and sort of help make the question less abstract. And I think that has proved to be, in a sense, quite self-limiting. We've now latched onto this imitation game test for whether computers show intelligence as being the only test for showing intelligence. It's become, in a sense, sort of self-limiting and self-perpetuating. And I think he would be a bit disappointed that we have ourselves lacked the imagination to expand out from that idea that we're still 75 years on, stuck in a trap that sort of he inadvertently laid for us then. If you think about it, we now define artificial intelligence by reference to the Turing test. And I think that most people who've thought about this, and certainly people in your lab, will have said, we ought to have abandoned it a very long time ago. And we need to think in a much more multi-dimensional philosophical way about it. Right, so that's all from me for the time being. Thank you for listening. I shall come.
Thank you so much, Dermot, and that's the perfect segue to our next speaker, who is a world-leading authority on the test itself. But before we get there, do you want to mention the other Turing anniversary?
Oh, well, thank you. I have bribed him liberally, by the way, with a business card. Next year is the 90th anniversary of a much more famous paper by Alan Turing, the one on computable numbers, with an application to the Entscheidungsproblem. And anyone who wants to know about that can talk to me about it in the coffee break. But this is, for me as a trustee of the National Museum of Computing, a massively important anniversary because of that paper. It's partly the reason why we're all here talking about computing, because without the paper on computable numbers, there would be no computers, there would be no computer science. So we're going to do a really exciting series of events and activities and talks and public education about computing and everything, really. Computing is still a subject that scares lots of people, and at the museum it's our mission to try and pull the sting out of that. And what better way to do that than to start with celebrating the 90th anniversary of where it all began.
And am I right in saying that where it all began is here? Wasn't it his master's thesis? So any master's students in the audience, no pressure.
Yeah, so if you do part 3 maths at Cambridge, then first of all, you're a genius. Don't speak to me in the coffee breaks. I won't understand the word that you've got to say. But then, so that's where it all began, in a part 3 maths lecture given by Max Newman. And he said, what are the essentially the constitutional rules of mathematics? How can we know? This was the sole unsolved problem set by David Hilbert at the beginning of the 20th century. How can we know whether a theorem might be provable or not? Is it actually worth your while as a mathematician spending time trying to prove or disprove a particular theorem? Isn't there some kind of test that we could apply to know whether you're wasting your time or not? is there a sort of mechanical process that you could apply to find out whether something is provable? Is it something a machine could do? You planted that seed in Alan Turing's mind. Is it something a machine could do? And then he comes up with the Turing machine. So one of our fun things we're going to start doing next year is we'll have a challenge for people to build Turing machines. So start thinking about that. Look out for the adverts on it. We hope we'll have plenty of entries from Cambridge.
Great, thank you. Watch this space. But now back to the Turing test. And we're very fortunate to have with us from Brazil, Bernado Goncalves, who well known to King's, where he's a much loved visitor to the Turing archive. Bernado is a research scientist at the National Laboratory for Scientific Computing in Brazil and a world-renowned authority on the test itself. Please welcome Bernado to the stage.
Thank you so much, Professor Cave, Stephen, for this nice, kind introduction. Right, so Stephen kindly suggested 4 questions for us in this panel, and I would like to follow them. The first question is that what was the original Turing test? Perhaps Turing was inspired by Wittgenstein in his idea of replacing one question by another question. In fact, he replaced the original question, can machines think, by his imitation game and test. But in fact, he posed several slightly different questions in his, I would say, discursive presentation of his test. Okay. So he constantly varied the design of his test, basically keeping the roles A and C of the deceiver and the interrogator or judge, while changing the types that would take those roles: woman, man, machine, human. So I'd suggest that a nice way to look at the Turing test is to understand his invitation to this generalized or abstract question: could A imitate intellectual stereotypes associated with B successfully or sufficiently to deceive C despite A and B's natural differences? So my answer to the first question, what was the original Turing test, is a thought experiment that was meant to illustrate the power of digital computing. So it's very nice that Dermot talked about the very origins of the whole Turing test concept, which lies in the Turing machine concept. I see some continuity between both concepts, right? So with digital computing, Turing foresaw, we would have a situation where types distinctions, like both natural and social types distinctions, hierarchies, could be blurred, right? With digital computing, anything intellectual could be imitated up to indistinguishability, right? So, of course, Turing also used irony, which is part of his philosophical style, and he explored like cultural aspects of this discussion. But his main point, I would say, was to explain to his colleagues and critics, as Dermot mentioned, the power of digital computing. He was keen to explore this prospect and, importantly, to warn us about this prospect. Okay. Let's also consider what the Turing test wasn't, right? It certainly wasn't a crucial experiment of sorts that could provide a kind of an existence proof of an intelligent machine. You know, you run a few times the imitation game, and as a result, you could have like, now we demonstrated an intelligent machine. I wouldn't go down that path. For Turing, I propose it was the actual production of the machines that would probably have some effect in convincing critics. Because, and I'm quoting, the idea of intelligence is itself emotional rather than mathematical. Okay, second question, what motivated Turing in proposing his test? I would like to use a secondary source here, Turing's former student, close friend, and literary executor, Robin Gandhi. According to Gandhi, the 1950 paper, I quote, was intended not so much as a penetrating contribution to philosophy, but as propaganda, right? Turing would have read the paper aloud to Gandhi, sometimes with a giggle, right? It's very interesting, this testimony. And Gandhi also emphasizes that Turing sought to persuade philosophers, mathematicians, and scientists. Again, as Dermot nicely described, he sought to persuade them about this idea, the power of digital computing, the idea that digital computers were not just sophisticated calculators, but were capable of behavior, would be in the future capable of behavior, which must be accounted as intelligent. These are the main colleagues and critics that Turing sought to persuade as he became involved with them in this public controversy in post-war England. There are some developments after the moments that Dermot touched upon the discussion with Jefferson, and that was 1949. But with Hartree, the discussion began a little earlier in 1946. And then in 1949, after the controversy with Jefferson that appeared in the newspapers and so on, Michael Polanyi, a philosopher at Manchester University, also got involved with this. And so yesterday we talked about tacit knowledge in the workshops. Michael Polanyi was the one who created this concept of tacit knowledge, and he was discussing that with Turing. So it's very interesting to see how ideas that we are discussing today about AI have a basis back then at this time. Anyway, they challenged and provoked Turing, and the Turing test can be seen as his response to them, right? As part of his argument in response to them. So third question, now we can connect some of the history of AI with the Turing test, is how has AI developed and fared against the test? Well, the beginning of AI research, in the beginning, the Turing test concept was really important and was even a long-term goal for the field. These early AI pioneers, Claude Shannon, John McCarthy, and Marvin Minsky, they understood the Turing test as a conceptual criterion for the idea of machine intelligence, for the very discipline and field they were founding. Two of the main sources for this are the Automata Studies collection and the famous Dartmouth AI seminar proposal. For example, in the Dartmouth proposal, McCarthy writes, I quote, "For the present purpose, the artificial intelligence problem is taken to be that of making a machine behave in ways that would be called intelligent if a human were so behaving." So I think we can see here the influence of the Turing test. It's like they were thinking about the field, about how to define the field through the lens of the Turing test. However, later, soon later, actually, Joseph Weizenbaum would, I would say, co-opt the idea of the Turing test. And Weizenbaum's research, which was very important indeed, was actually about conditions under which humans may come to anthropomorphize machines, right? And Weizenbaum's reinterpretation of the Turing test would become influential, would become the basis for initiatives such as the Loebner Prize competition that appears later in the 90s, as I will mention, but becomes the basis for this idea, this maybe simplistic idea that the Turing test was only about deception and was only about building a machine that could just appear to be intelligent and not necessarily be intelligent. So I say it becomes the mainstream view of the Turing test, right? In the presence of practical Turing tests, it's almost like this idea hijacks the whole concept. And when people think of the Turing test broadly, they tend to think of practical Turing tests. But I would dispute this view, right? So the Turing test is widely seen sometimes as just a social experiment, or even in the words of this computer scientist Moshe Vardi, just a game. A fellow historian of computing, if you allow me to make a joke, told me once that practical Turing tests that recruit humans exist because there is no analog for humans of the Society for the Protection of Animals, you know, because people get recruited into these tests, and maybe it's if the experiment is defined with the purpose of, you know, now we can announce we have an intelligent machine, it's more like a pseudoscience kind of thing. Anyway, in the wake of practical Turing tests in the mid-90s, AI research started to see the Turing test as a sort of a flawed scientific experiment, an experiment that should be fixed, maybe could be improved. And then researchers have repeatedly attempted to devise new tests or modify or extend the original Turing tests. And none of these proposals became widely accepted or popular. So the fourth and final question, what new tests have emerged? I won't mention any of those failed attempts. I will mention that AI research in the mid-80s went through its winter. And then at that time, we have machine learning research emerging alongside this concept, the common task method, developed by Charles Wayne at DARPA. And then we have the idea of benchmarks, and benchmarks would become like the main evaluation framework for AI and machine learning research. And since then, we have seen the widespread adoption and use of AI benchmarks, and we still live with them. Although it seems that there is a growing consensus about their limitations. So looking ahead, I'd like to suggest that the Turing test may have a comeback, maybe now as a proper evaluation framework for AI, right? I would like to suggest the idea of automated Turing-like tests. We can have machine against machine, as proposed by Jose Oralo in his writings about the Turing test, so that we replace the human evaluators with the subjectivity. I mean, in the context of seriously evaluating AI systems, right? We can replace human interrogators with machines. And I would suggest that the important thing here is that the evaluating machine should not be a black box to us, right? So that we can have a chance at staying in control. So I will stop here and hope that we can continue the discussion. Thank you.
Thank you, Bernardo. Please come and take a seat. And so now, after our two esteemed visitors, we turn to local talent and Cambridge's historians of technology. First up, Amira Moeding. And Amira is just finishing their PhD in intellectual history here in Cambridge. And they've already established themselves as a rising star in the history of computing and big data. Amira, over to you.
Well, thank you so much. I'm incredibly grateful for the invitation. I'm also incredibly grateful to learn from all of you in the discussion in just a second. And it is truly an honor to speak in such eminent company. So after Bernado's talk, I'm actually quite glad because this takes off quite nicely, because there recently has been another practical implementation of the Turing test. And turns out, so they did the proper thing, right? They had a machine in the game, they had a human in the game. The threshold was 70% of, the average people, as Turing puts it in his test, evaluating the person against the machine. And it turns out that in over 70% of the cases, the people picked the machine instead of the human, which brings us to this nice relationship here, right? At what point do we think of humans as machines and of machines as more humans than humans, possibly? And I think that's something to keep in mind, and that goes precisely to the question that was raised. To what degree is intelligence maybe an emotional concept? And the whole thing, hence, very subjective, and we need to think very differently about the Turing test, as was just pointed out to us. So I want to start with, you all know the Turing test, I've just laid it out a little bit. I want to start out with 3 observations that I always found incredibly interesting about the Turing test. And so first of all, the question, is this about thinking? Are we simulating thought? Or are we simulating intelligence? And I think Turing goes in many ways back and forth in the paper, but we usually find the notion of intelligence when he's speaking about learning, when he's speaking about a machine that he imagines to be interacting with the world in some direct sense. And there often, to me, this image of embodiment comes up. So, that's very different from the simulated thought, and he keeps that very strongly. It's simulated thought that's happening, that comes from digital and more abstract, if you will, data, and not from direct perception. And I think to this day, we should think about, well, what does it mean if our computers, if our AIs do not perceive the world? If anything, they perceive the world of the web, right? And we have to think about the question, well, what does that mean for the intelligence that emerges from that type of perception? The other point that I want to raise is Turing actually in the paper reminds us, and I think it's a good reminder, to keep in mind that we're speaking with intelligent people, and that the polite assumption is that our interlocutors are actually intelligent, right? And I think he's right about that. But within the setup of the imitation game, that means we have an interrogator who assumes he's already speaking to humans, right? And who kind of, makes his or her judgment on their intelligence, and is already prompted to be polite, which, that's a subjective judgment. We have the whole egalitarian setup here of like, we want more than 70% to judge like that, which brings us into, politics, which is usually what I deal with, namely the question of how do we want to mix science and politics together? And do we want the expert's judgment? Do we want an egalitarian judgment? Or do we take intelligence seriously as an emotional, kind of subjective human judgment, and hence want to bring in a majority of people? So all of that is in there, and I think incredibly fascinating. And then, exactly, everybody already assumes that the players are human. And one thing that always fascinated me, and I'm going to take you down the road of an analogy that I really, really like about the Turing test. So if we have to take seriously that the simulated thought is happening, if that's the only test we have, we see simulated thought, we assume it's thinking. Well, if we assume that the man is a woman, do we actually have to take seriously that he, in fact, is a she? And I personally very much like that assumption. It's bringing Turing and Judith Butler a little bit closer together. But obviously, it's up to you what you do with that. Okay, so that's a Turing test. But as Bernado has already pointed out for us, well, methods and testing regimes cling together, right? When we test, usually, when we have specific methods, we run different types of evaluations and tests. And here we have the emergence of a first very thin idea of a benchmark happening, where understanding isn't defined broadly as human-like, but suddenly understanding becomes a thing where you have like, okay, as long as it answers, 70% of the questions right, then okay, we assume that this is understanding, and that's it. No thick concept of understanding here, if you will. And that comes out of development in the late 1960s and 1970s, where speaking of AI, kind of falls out of favor because people take it to be unscientific, unscientific, broad talk. We actually have no way of properly testing this. Often this is assumed to mean that also funding stops. Funding does not stop. Just people call their experiments no longer AI experiment. Okay, so this is like a first kind of like, okay, we're narrowing our problem down quite a bit, actually. We're no longer pretending to be women. We're just trying to get some answers right on questions. And that continues. The more data-driven the field becomes, the more big corpora become available, the more the benchmarks, and I'm now talking about benchmarks, narrow down. We kind of like test for very, very specific tasks, and we've already heard the name Max Liebermann, thank you. And this comes out of, DARPA decides there is no clear progress in this field. We can't actually evaluate progress in this field. So we're going to start testing different research groups against each other. But what do we need for that? We need shared training data sets. We need shared test data sets. And now we can evaluate specific algorithms on and shared tasks, obviously, on very specific tasks and suddenly trace these like minimal improvements. And Mark Liebermann actually at one point says two things that I find very interesting here. First, he refers to this as the gamification of machine learning and actually puts himself in the position of, I don't know if you know a Skinner box, but when you have the little rat and they push the button over and over again because this is gratifying. That's how he sees himself in the setup of like, yeah, I'm just trying to improve the algorithm. And every 0.2% of increase is suddenly, a reason to bring the champagne out. And that, again, that's no longer testing for intelligence, right? That's testing for improvement on a task, and it's tiny tasks like feature recognition. So we've moved quite far. And now we have LLMs, and we have things that are actually conversing with us, and we have things that obviously show, like, convince more people that they are human than actual humans do. And here we go. Here are Sam Altman, David Deutscher, and some German person from the Springer Press. I don't know his name. Sorry, he's moderating. And David Deutsch, who's a physicist at Oxford, challenges Sam Altman on the idea that LLMs are actually intelligent. And Sam Altman proposes this new test. So if we can get ChatGPT to bring us unified field theory and tell us how it got there, dear David Deutsch, would that satisfy your kind of like threshold for intelligence? David Deutsch says yes, and that leads me to consider a variety of problems of like, how do we falsify, let alone verify this? How do we go through these proofs? And what does it all mean? Which brings me to a bunch of open questions. I've already said, testing methods link up with the methods of the field. And so we really have to wonder, what are we currently testing for when we test these black boxes? What do we want from a benchmark or a broader test? Really, that's a normative question, right? What kind of intelligence, if we want to call it that, do we want? And what level of generality can we actually test for? So thank you so much.
Thank you so much, Amira. Please come and sit down. Yes, and those questions are fantastic for setting the agenda for the rest of the day. It's now my great pleasure to welcome another of our local talent, Jonnie Penn. Jonnie's an associate professor of AI ethics and society here at Cambridge, where he leads our extremely successful as in Lieberman Center for Future Intelligence Master of Studies program in AI ethics. And I'm glad some of our students and alumni are in the audience today. But Jonnie is also a renowned historian of AI. So Jonnie, over to you.
Thanks, Stephen. Thank you, fellow panelists, and for everyone who's come today. I'm going to be picking up on kind of questions 3 and 4, because I think you've been in really good hands with the previous panelists, and I want to kind of think about the legacy portion of the topic that we're all brought together to consider today. And is the title, the next Turing tests. What would be worth describing as something as influential as this? So to do this, I want to look at an undercurrent in the development of the histories of AI that the Turing test, I think, epitomizes, and others have said the same, which is behaviorism. And I'll just read this quote: the Turing test at first blush is a paradigm of behaviorism. Turing says outright that the question of whether machines can think is strictly meaningless and must be replaced with the question of whether a machine can pass the imitation game. And as you've heard, Turing did a lot more than just this. There's different ways you can interpret this. But let's unpack what this has meant in the histories of AI. Well, one thing we know from his computing machinery and intelligence paper is, there was in the air at the time interest in kind of two paradigmatic approaches to AI. One that you can epitomize through chess, and one you can epitomize through the learning of a child. One being kind of abstract and trying to understand, the kind of what it is about intelligence that makes it, operant and useful. The other is more passive and just observing, as a child does, how we kind of store the world around us in curious and often useful ways. But if we look at this graph of publications, in AI or around AI since the 40s, what you see is here we have the kind of earliest work on connectionism. So this is kind of the cybernetic era. 1950, we had the Turing test introduced. And even though my little boxes cover some of this, what you see is in the earliest years, in the kind of first decades of AI, and many people forget that Alan Turing never heard the term AI, right? He died before that term was introduced. And what that tells me is that when Alan Turing and AI are stuck together, it's important to unpack the kind of uses of history. What work is Turing's legacy doing in these equations, or in equating them? And of course, we know that conceptually, as you've just heard, he kind of his work was prefigurative to AI, but the term itself he wouldn't have used. But we start to get the beginnings of a field. We get symbolic AI, which is premised around the idea that intelligence could be reduced to a string of symbols. So this is the chess approach. There is a code behind intelligence, and perhaps there's a grand theory of intelligence. This group of men thought that we were awaiting our Newton, that there would be some individual, probably a man, they thought, who would just crack the code, and then we would be able to manufacture intelligence in machines. That turned out to be difficult to prove. We haven't had that person arrive yet. We haven't had that code cracked. And so their ambitions gave way later to what are known as expert systems. Still in the symbolic paradigm, but the ambitions were slightly lower. Rather than accounting for all of intelligence, trying to account for intelligence in particular silos. So if you sat down with a doctor at the NHS and said, how do you diagnose a migraine? And then talk to them for a few hours about that, and then codify their decision tree and put it in a machine, that's expert systems. And what this leads us to, and where we are today, is to connectionism. This was the first era in which AI systems were commercialized. So the NHS used them, oil and gas industry used them, other parts of industry used them, which is a big deal. But sitting with people and interviewing them for 2 hours, it's slow and sort of tedious. And what connectionism allowed, especially as we move really to kind of like here where we are today, is instead of doing interviews and deriving your insights that way, drawing on and deriving patterns from large-scale behavioral data sets, right? So this approach takes off as we have the origins of things like big data, that we are tracking ourselves or being tracked in new ways. But throughout all of this, you have the commitment that even if you can't explain, actually after about here, I would say, you forfeit the ambition to explain the inner workings. You attempt it, but you don't need it. And this today is understood as the bitter lesson. So I'll read this from Richard Sutton. The biggest lesson that we can read from 7 years of AI research is that general methods that leverage computation are ultimately the most effective, and by a large margin. And so you see, since the 40s, this massive kind of brute force effort to just throw more compute at the challenge and hope that that gives us some insights, because we can't get very far with theory, right? And I think this was a GIF initially, it's hard to see, but from Zoolander, when they're kind of hitting the computer and saying the files are inside the computer. It is a kind of submission to behaviorism. We don't know what's going on inside, but we know if we do these inputs, we'll get these outputs. And that turns out really useful, right? That's the bitter lesson. Now, along the way, one of the things that we have lost touch with, I think, and this is where I'll shift towards the kind of future of the Turing test, is our relationship to energy. So John von Neumann, who is a contemporary of Alan Turing, when he died before AI kind of took off as well, but he said, the trouble with logic is it doesn't exist in time. And so we can have these brilliant insights about the logic of this or that, but if it doesn't exist in time, it's quite a different thing than what you and I inhabit temporally. And one of the differences is the relationship to energy. And in our lifetimes, many of us here, we've seen that the tech industry has had to kind of put its energy use behind a curtain somewhere, right? So it's not that our smartphones are adequate to do certain tasks. They have to access the cloud, and the cloud has to be run by data, on data centers that are far afield and by power that we don't really think about, right? It's just kind of over there. And it doesn't, I don't mean to suggest that we're not getting better at energy use and computing. There's heavy incentive to do so, but that intelligence and energy, in part because of the history of behaviorism, have been kind of dislocated. Now, where does that leave us kind of moving forward? It troubles me a great deal that we talk about the tech industry in some part as a tech industry, because where a lot of these tools are being developed at places like Google and Meta, they're more like ad businesses than tech businesses, right? That's their bottom line. And it doesn't surprise me that we would have suggestions like this from Mustafa Suleyman, who's a founder of DeepMind, is now a major player at Microsoft, saying that the new Turing test would be to see if AI can make $1 million. And it reminded me of the scene from the movie Idiocracy, where they realize that they're watering their fields with Gatorade because it has electrolytes. It's just kind of, it's a kind of dislocation from reality, that the future of intelligence is a sum earned. That seems to me both kind of worth challenging, even if you can draw certain insights from it about where we are in the world, but also understanding it as a form of energy arbitrage, where if you are in Silicon Valley these days, you'll know that the race isn't really for compute anymore, it's for electricity. And that's the bottleneck. And if you can make $1 million by spending less on the infrastructure that it costs to make $1 million, you've got a business case to pursue this line of investment. And I think a lot of the future of AI will be kind of directed by this assumption, right? Now, the challenge is that this is a very expensive way to go about things. You've probably all seen in the headlines, trillions of dollars worth of investment happening right now to make the data centers that will power the next stage in this history of kind of behaviorism rendered through AI. And people like Mustafa have said, this amount of investment is going to have peculiar outcomes, one of which is what he calls AI psychosis. And the worry here is that we are kind of embodying, or we are allowing a political economy that sort of necessitates maximal value extraction. So if we put $6 trillion into this infrastructure, or even $3 trillion, that money has to be made back. How will it be made back? It must be extracted from the worlds that we live in. One of the worries that my colleague Jakob Chowdhury at CFI and I have written about is what we call the intention economy, which we see as the successor to the attention economy. And the long and the short of it, and I'm near my end here, is that what has been treated on this panel and is often described as a bug, that machine learning systems can deceive us, I think mistakes the entire political economy that we live in. It is a feature. If you work in the advertising industry, your job is to convince people to do things. If you have a superhuman tool for persuading people to do things, you have a shareholder responsibility to use that tool. And I think this sort of outcome, it's not going to be that suddenly they're convincing us that the world is flat, but you give it a couple of years, but they will be convincing us or stewarding us through these shared AI computer environments in ways that distort our understanding of reality, maybe to buy products, maybe to elect certain candidates, et cetera. And that's what, I won't dwell on it, but that's what we're kind of talking about in the intention economy and concerned about. But I'm here to talk about the next 75 years. That's where I'm going to end, right? What could we do differently? Well, there is an alternative vision that Turing was pursuing in the final years of his life that John von Neumann was equally interested in, and it has to do with the natural world and energy. So in this paper from 1952, Turing wrote about patterns in nature. And basically, he and von Neumann, both eminent mathematicians, were interested in how it is that if you've ever worked in a garden, that complexity comes from simplicity. How can you have a seed that grows into something so beautiful? Mathematically, what is at play there? And they were both interested in basically how mathematics could change by incorporating our understanding, our improved understanding of the natural world around them. And so where I'm going to end here is thinking about the future of AI in relation to the natural world and energy in particular. This great book by Masita Chiramata, The Brain Abstracted, which won a prize, it's a history of neurology or neuroscience. She writes about a related insight this way. She says, one significant point of difference between minds and computers is that the hardware of electronic computers is engineered not to undergo material changes with use, whereas there's an inherent tendency for biological cells whose material constitution is changing as they metabolize to undergo use-based plasticity. So all of us in the room here today have a metabolism that dictates our use of intelligence to some degree. Will this keep me alive? Do I need to store this energy to tomorrow? It is a part of our identity. And these are gifts that won't work here because of a technical thing. But basically, I think what we are overdue for, and the best possible use, I think, of machine learning today would be to give AI a metabolism, recruit it into the management of its own energy, and to have it live amongst us by having to not just have energy as a tool, but have energy as a matter of identity, which is more what you see in the natural world than we are seeing in AI today. And part of what I'm saying, the subtext of this, is it may help us steer away from this kind of this seismic investment in AI, which creates all these perverse incentives that I think steer us away from all the benefits that this tool set can bring us. So that is my presentation for today. Thank you very much.
Thank you, Jonnie. Thank you so much for so elegantly pulling out all of those themes in the paper and connecting them to the present moment. It sounds like the comment that we all have a metabolism, but it takes our use of energy and intelligence ought to be a segue to the coffee break. But we've got 20 minutes of questions before we come to the coffee break. And so please have a think about the questions you'd like to ask. In the meantime, I want to pick up on one of those themes that was, very much in Jonnie's talk, but I think implicit in the others too. And of course, Turing didn't call his test the Turing test; he called it the imitation game. And imitation and deceit and manipulation are therefore inherent in it. Now we have machines that can pass the Turing test, but of course they can't just do that. If you have a Turing machine that can deliver a human-like performance, there are a lot of other things it can do, which is superhuman. It can be the AI chatbot, boyfriend, girlfriend, that's very human-like, except for it never sleeps, is always there for you, never loses patience. The AI chatbot that is convincingly your best friend, but actually much better at selling you stuff, for example. So how much is this also part of Turing's legacy?
This is somewhat controversial.
Jonnie, why do you think we invited you?
Well, I think it's interesting because I don't have a kind of well-formed thought on this, but the fact that Turing died at the hands of the state to some degree, or a culture that would not accept him as he is, you can't subtract that from who he was, right? But you can understand it in terms of his legacy. And I think that's what worries me is if Turing were alive today, would he be much safer in the world? He would be in some ways, but the way things are going, he might not be. And so what do we owe Turing, I guess, rather than what did he give us, is what's fascinating. And I think you picked up on that with the gender question in the imitation game, but yeah.
Thank you. Amira, did you?
That's actually great because I can just pick up from that, because I think one of the things, and this is less about Turing and the Turing test, but about our understanding of history maybe, one of the things that history can teach us is responsibility, not just to future, but to past generations. And I think Jonnie's very right when he points out, well, maybe we owe Turing something as well. And I think, the question of deceit and intelligence, and, I think to me, we're very much going back to the question of like intelligence as a subjective concept, right? Like it's a value loaded term, and we always create it. And at the moment, we're back in a stage where we think Elon Musk is incredibly intelligent.
I don't.
Yeah, but he's set up as a genius constantly. And at the same time, all of these geniuses are very much in the business of destroying the planet as well, right? I'm not saying that's the only thing that they're doing, but they're doing that as well. And I think we have to kind of reconfigure our ideas of what intelligence is and what we want from it. And I'm always, I think, because I'm a data person, the passages in Turing's paper that fascinate me most are about the question of storage, about the question of what do we actually need to kind of like generate this, which brings us back, I guess, to Jonnie's final remarks around, and that's also there, right, in the paper around embodiment and metabolism. And so I think as long as we're creating something that doesn't have needs in the same way, which picks up from your kind of like AI girlfriend boyfriend question, as long as we create things that are, well, little fantasy gods in a way, except that in the case of especially AI girlfriends, we can also completely kind of oppress or submit them, which I think is part of the fantasy there, right? As long as we're building tiny gods, we have not come to terms with our own humanity in many ways, and I think we should start to do that.
Thank you.
I'd like to chip in on this. I wonder whether we have got ourselves stuck in the 21st century in the same kind of mindset that the mathematicians were in when confronted with computing machinery in the late 1940s. We are obsessing endlessly, not just in this room, but outside as well, about machinery that behaves like humans. And we talk about it endlessly. We talk about how we're being manipulated by machinery, or the philosophy behind the purveyors of AI models at the minute. It's all about the extent to which machines can imitate human beings and manipulate them. This is not about intelligence at all. Intelligence is something completely different. And yes, all right, thank you, Bernardo, for pointing out that Alan Turing says that the concept of intelligence is an emotional, not a mathematical concept. I think we need to remember that. This is why we keep being magnetically drawn back into this thing about humanity and machinery that is trying to imitate or behave or manipulate humanity. A more general intelligence, and we'll talk about this later today, I'm sure, but a more general intelligence may have nothing to do with humanity other than the fact that generations ago, the machinery that enabled that to happen was invented by humans. I think we can't imagine what an intelligent machine might think philosophically about the future of machinery. Yes, it's going to have a piece about sort of where am I going to get my energy from, which is actually, and I think that's another trap there, because I'm now asking you to think about machinery in terms of biological organisms. Maybe that's wrong. Maybe machinery is not going to behave like an ant colony. You know, I think we need to expand our imaginations and actually do some thinking, some intelligent thinking about what machinery might want for itself if let off the leash of having to behave and manipulate like human beings. And I think that's probably where we're going to come on to this afternoon. But this is kind of where I was headed in my opening remarks, which is that the Turing test constrains us, it imprisons us, it forces us to think too narrowly about a much more important, wider concept. Let's not get mesmerized by the fact that somebody very rich in California is trying to manipulate us and trying to get us to believe that he, and it's a he, I'm sorry, it's definitely a he, has invented something called artificial general intelligence, and it's just around the corner even if he hasn't invented it this afternoon. It's not, it's marketing, it's hype. Get over it. Let's move on and talk about something more interesting.
Yeah, thank you. And I love how you're all bringing out the extent to which the Turing test, by putting it in its time, was extremely political, even if that's not what Turing himself intended. We don't know, and there are so many layers of irony as comes out in Bernado's work. But intelligence is, of course, a very political concept used in the mid-20th century to put people into hierarchies. And this idea of passing, can a machine pass as human, would have been an incredibly important one at the time for those who weren't part of the establishment, right? That, you know, can a gay man pass as straight? Can a person of color pass as white? And so on. But let's open it up to questions. Yes, Apolline.
Shows us how the Turing test indeed takes many important features of intelligence, so out of the picture, embodiment, needs, metabolism, gender, etc. And I found it quite interesting that throughout the presentations, there was a mention of the intellectual context in which Turing is writing, mentions of debates around behaviorism. I think Bernado Goncalves mentioned at some point. So I was just curious how, in your view, the Turing test is also revealing as something of the contour world in which Turing is writing of all these considerations about freedom and alienation, about the social function of science, all about the
Thank you.
Yep.
Big question. Bernado.
Those colleagues of Turing's, especially those three that I mentioned, they were very much concerned about freedom, right? And they conceived machines, the idea of intelligent machines, as something that would like resemble Soviet politics, Bolshevism, something like that, right? Because they thought this is a view of the human as a mechanical being, right? Who can't think, you know, and this is dangerous. And then, you know, it appears even in the newspapers in the 1946 moment of the controversy. Douglas Hartree, even mentions this is a path that will lead to tyranny and Nazism, the idea of machine intelligence, right? However, Turing was, of course, scientifically curious about those prospects, but he was like, I wouldn't say that he had a very clear agenda for this whole research in machine intelligence. He was actually, and it's interesting to see how he was sensitive to those criticisms, because he engaged with these people. He even, I would say, changed his mind in some aspects, and even eventually made that shift to morphogenesis, as Jonnie was saying. He wanted to explore these biological aspects of intelligence, or how organisms grow in a very natural way. In fact, the idea of the concept of artificial is something that you will not find in Turing's writings. He conceived the whole thing as very natural. And during the war, so the idea of the abstracted brain, in some sense, is related to the Enigma code breaking thing, right? Because it was useful to abstract the problem of communication exchanges, ciphered communications. But so eventually later, Turing would shift his research to mathematical biology. So it's very interesting to see how he was able to listen to criticism and to consider multiple aspects of these things.
It's notable that some of Turing's critics we would consider perhaps romantics, that is, those opposed to the kind of rationalism that they thought he personified. And of course, this is a time when, I mean, they were living through, they were witnessing these tyrannical surveillance states trying to impose a certain kind of rational order at human cost, fascism and communism. Jonnie, I know you've written a lot about the emergence of computing and its relationship to a sort of authoritarian bureaucracy.
Yeah, well, no, it's a paper I really want to write, which is you may have seen this famous photo of all the early AI guys at the Dartmouth Summer Research Project working with Turing's ideas. This has come out in this panel. And most of them were like card-carrying Marxists at the time who were worried about government and thought, what if we had computers do government instead? And I think that dream has soured a little bit, not because the tools are innately, authoritarian, but they're awfully useful if you are an authoritarian. The surveillance state of the 50s kind of pales in comparison to what we live amongst now. But to your question, Apolline, about the Cold War, something that fascinates me is that the Americans in particular were interested in how to quantify progress in Cold Warfare. If you're in hot warfare and you have, casualties or munitions, you can measure where you are. But they needed things like systems analysis and game theory and AI to help them quantify, like, how are we doing? And how do we make sense of uncertainty without clear metrics? How do we use statistics to do this? So yeah, like the perceptron, which is the first model, one of the first working models of machine learning, was premised on Frank Rosenblatt's research on, can you study a broken family by asking questions like, does mom get out of bed before noon? What happens when mom and dad fight? He'd asked all these Cornell students these questions. And so, yeah, as I say to students in the MST often, like, ideals about how society works have long overlapped with ideals about how the mind might work. And I think a lot of my work is trying to just remind us that we don't know as much as we think we know. And I think that's the hubris of the legacy of AI, is there's all these kind of crutches that seem pseudo-intelligent that upon digging into them are not as strong as they might seem. They're misused in a sense.
Mm-hmm. Thank you. Another, yes, question. Yeah.
Thank you very much for your wonderful talk. So I wanted to add to the point of rationalism that you raised. So I was wondering to what extent you think the very concept of intelligence is actually biasing us to limit how we think about the goal and purpose of AI. Because a few times in the discussion you raised that, well, intelligence should be more subjective or emotional like it is. Maybe it's because we're not really thinking about intelligence anymore. We want to think about something a bit more subjective and qualitative. And like a simple example would be like, if we think more in terms of the contextual social value of AI. Currently, we're thinking about how well can ChatGPT generate an essay, and then we're measuring its intelligence, its human-like intelligence. If we think about the contextual social value of AI, which is more about how we evaluate people and their different social functions, it'll be, to what extent does the person using the ChatGPT feel more empowered and capable of writing an essay or better at doing the things they care about? Because I feel like maybe, yeah, the concept of intelligence could be biasing us to limit how we think about the problem. I was wondering what your comments are.
Thank you, Lisa. So is your question partly, we focus too much on the intelligence, whatever that is, of the machine itself? We ought to be testing instead the ways in which the machine is empowering people. What is it actually doing in society? What's it doing to real humans? Any thoughts?
Turing?
Yeah,
Sorry.
please do, and then Amira, yeah.
Turing was very hopeful that machines could also help democratize power, let's say. As Dermot mentioned, the women who were the human computers at the time were just about to be displaced. And Turing was the only, as far as I know, the only computer pioneer that noticed that and talked about that, So I think that there is a question of power also here, and he was very hopeful about this. It's complex, but maybe there are some interesting things that will happen with intelligent machines.
Thank you, Amira.
I think you're completely right in the sense of like pointing out that, thinking through intelligence within the history of science, usually, intelligence comes up around in the context of eugenics. And then the way I phrase it, usually for myself, when I try to explain to myself what's happening, I'm like, okay, so this is a concept that is inherently stabilizing oppression. So when concepts of oppression shifts, conceptions of intelligence shift as well, right? That's what it does discursively. So intelligence is not really a thing. And I think when you point us to the uses of kind of technology and where it is empowering, I think it can be incredibly empowering. There are like all these studies coming out of computational linguistics right now where, ChatGPT can help researchers to, like, especially from non-English speaking countries, to submit their papers more quickly. That's, yeah, I'm all for that, great. Like, nobody should be casted out because basically their writing has an accent, right? I think we can all agree on that. On the other hand, it kind of standardizes English in a weird way. As I kind of pointed out in the beginning of the talk, it also makes it appear that we now think ChatGPT sounds more human than we do, and I think that's just something we could think about. And then finally, again, this is, to me, the current iterations of AI that we have, LLMs, is so fundamentally an industry project that I feel constantly inclined to question the uses. So while this example that I just mentioned, it's amazing. Do I want it at these energy costs, right? Do I want the casting aside of minority languages that comes with it? So what do we get out of it, and what do we put in? But I do think it would be great if we could refocus the conversation on social and political problems and the uses we actually get out. Yes.
There's a new book by Leif Weatherby I'll offer to the room and anyone watching this called Language Machines, which is really interesting. And in it, he basically says that the history of cognitive science, they've kind of overplayed their hand in suggesting that there's a biological basis for things like intelligence. Like, from what I understand, Stephen, you'd be better positioned to speak to this than I am, but we don't have a theory of intelligence. We don't really understand, like, intelligence is not a deeply scientific concept. We do not have a grand theory of it in humans, let alone machines. And to me, it's kind of like cute that the industry talks, because of behaviorism, like, well, we'll get these benchmarks and we'll show that the machines can do it according to like these really peculiar benchmarks that we play a hand in choosing. Like, okay, cool. But what he's saying is that, like, we must not get stuck, or I'm interpreting him as saying, I should say, Weatherby, that we should not get stuck in the platitudes of human, intelligent, these concepts that are kind of wielded as oh, you don't get it, because if you look at them, they're not as strong as they're being positioned. They don't hold the weight that I think technical practitioners who are unreflective can sometimes suggest. And what Weatherby's ultimately arguing is that because these systems are not premised in biology, because they're premised in culture, they are cultural machines, we are positioned for kind of a revenge of the humanities to say, well, we know a lot about culture, a lot more actually about culture than other disciplines. So let's chat. And I have said in the past, and I stand by, I think we are living in the world, we're living in an AI world. This is what it feels like. But if we want a different version of it, we have to enculture it differently. And I think there's like little mind traps that we get in talking about humanness.
Mm-hmm. Well, I'm enjoying all of these emphasis on the importance of interdisciplinarity. Now, we have a very interdisciplinary center, of course, and that's part of the strength of Cambridge colleges. We're out of time. Dermot, any final words?
Well, I'm very encouraged by all this, if I may sound patronizing for 1 second. I've been going to conferences about AI for many, many years. It's something to do with having my surname. I get invited to this kind of stuff. And it's very interesting how thinking has shifted in the last 10 years. One thing that ChatGPT in particular has done is it's brought the philosophers and the AI specialists into the same room. Whereas 10 years ago, I was on a stage where somebody in the audience asked the panelists what they thought about whether the machines were going to take over kind of thing, which is a classic Alan Turing. quote himself quoting from Samuel Butler. And the panel was, to my mind, extraordinarily dismissive. They said, you watch too many sci-fi movies. The ideas that the audience wanted to explore about where are the issues coming out of AI were the province of the philosophers who were not considered technically adept and allowed into the same room as the computer scientists. We've changed that. That's a fantastic thing. It's great to be able to participate in a debate like this where people can say, I don't care whether you're a computer scientist or a philosopher or whatever your background is. I mean, you're an HPS person. Oh my goodness. We're allowed to discuss it with each other, and we have a much more fruitful and hopefully positive outcome kind of discussion. So yeah, thank you for inviting me, and thank you for facilitating
No, that's the
this.
perfect note on which to end this very interdisciplinary affair. Metabolic needs call. We're going to take a short coffee break, and then we will reconvene here. I will hand over to Umang, and we will talk about what the present holds. But first, before you head off into break, please join me in thanking our excellent panelists for that very rich discussion.